my great pleasure to welcome you all to this panel. I'm Tom Sawanabori, the CTO for CTIA. We're kicking off this session with a great lineup, and I first want to take a few minutes and highlight over the past year or so since we did this last year what some of the key accomplishments that our industry has made, first particularly in 4G LTE. The operators in this room and around the country have deployed 4G LTE to over 300 million POPs. So nearly every part of the country is covered. As Mosaic's reported, over 99.6% of the US population is covered by 4G LTE. And that's an amazing feat when you think about we only started this about 6-7 years ago. So a very short time period to deploy a massive amount of capacity and coverage. And in that same time frame, over 97% of the people have a choice of 3 or more operators. So we're bringing more and more coverage to folks, including rural America. And then secondly, you think about LTE Advanced, the technology advancements, including in particular 2 carrier aggregation, 3 carrier aggregation. Our panelists are going to talk more about that, bringing better coverage, better capacity, better speeds and throughput, more performance for our customers, both on the downlink initially and then ultimately on the uplink. And they'll talk about other techniques like higher order MIMO antennas, small cells, to bring benefits to consumers. And lastly, there's been a lot of advancements in 4G LTE to prepare us to accelerate the Internet of Things. So you've got Category M devices being developed and rolled out now, along with narrowband IoT. So we're in a great place. We're leading the world, one of the global leaders in 4G LTE, as demonstrated by our coverage, our performance, and the number of customers. As of the end of second quarter, we have over 250 million customers using 4G LTE in the United States. But we're not standing still. The operators and folks in the ecosystem are moving quickly towards defining 5G. There was a lot of discussion about defining things in next generation mobile networks in the industry standards groups called 3GPP. There's been a bunch of trials that have been announced, and some of the panelists will talk about what they're learning so far in their trials. And last but not least, we've also secured an order from the FCC in July with high-band spectrum. The FCC voted unanimously to make high-band spectrum available, so we'll continue to press them on moving forward towards making that spectrum available in a timely manner, and we'll definitely need a suite of low, medium, and high-band spectrum in order to make 5G a true reality. So we're paving the way for global leadership in 5G, and I just want to show you a short video to give you a glimpse of what the future holds in terms of 5G. Oh, in a moment I'll introduce our panelists, but I want to show you the video first, and then I'll introduce our all-star lineup.
America leads the world in 4G mobile, and it is about to get even better. 5G. Faster speeds. Connecting everything. In real time. America's wireless industry continues to innovate to support your mobile-first life.
All right, so a lot of great things to look forward to. Faster speeds, lower latency or more real time, and ultimately, when we get a lot of density of the Internet of Things, we'll need to move to 5G as well in the IoT space. So let me introduce our great panel lineup this morning. I'll start with Tom Keithley and ask him to join me on stage. Tom Keithley, Senior Vice President of Wireless Network Architecture and Design for AT&T. Ron Marquardt, Vice President of Technology, Innovation, and Architecture for Sprint. Kari Kawapamaki, Vice President, Network Technology, Development, and Strategy for T-Mobile USA. Mike Irizarry, Executive Vice President and Chief Technology Officer for US Cellular. And Adam Coppy, Vice President, Network Technology Planning for Verizon. Thank you very much. I'll ask each one of our panelists to come up here and talk for a few minutes on kind of what they're doing to lead 4G LTE, what they're doing in 5G, and then we'll get into a series of questions that I'll ask the panelists. And if you have a question, we'll leave a few minutes at the end for audience questions. So think about your questions, write them down, and be prepared towards the end of the panel. Thank you.
Thanks, Tom. It's pretty clear AT&T is different than the rest. You'll notice I have a tie on. And the reason for that is I got here first, and before I saw everyone else did, they already had the microphone on there. So that really is the only reason. I thought I would start, though, by picking up on some of the comments Tom made about our network today. We're going to talk a lot about 5G, but there's so much going on with existing technology. I want to mention that. If you look at our LTE networks, basically the industry is in the process right now of densifying. We're putting in a small cell layer, and that layer is actually using a lot of fiber that we're deploying as well. And that's all about being able to deliver the performance. If you look at bandwidth, many LTE Advanced features right now are underway. You're hearing a lot in the news about what we're doing with carrier aggregation, with higher order modulation, some of the other more advanced features, and that's about delivering performance. This network's going to be around for a decade or more, so you're going to see lots of new innovation in the actual networks today. There's actually a path for us to achieve 1 gigabit per second peak speeds on the LTE network, and you'll see that as a reality in the next 12 to 18 months. If you look at the other end of the spectrum, where we have IoT and some of the smaller bandwidth, Tom already mentioned Cat-M and narrowband, but for the first time, we're going to be able to deliver extended range. We're going to have low-cost modems, and we can deliver a 10-year battery life. It's things like that that will actually help us unlock the potential of IoT and make that a scale deployment. So with that, I'm going to stop, but I just wanted to mention lots of new innovative things coming on the existing technology, and that really will be the road we follow to deliver 5G. Thank you.
Thanks, Tom. Just to carry on with that theme, I think this is a very interesting time to be having this panel. We have a lot, as an industry, we can look on, and with LTE with success and a lot of great future here with 5G. Looking back over the years and generations, I think it used to be that a couple of our companies here would have one technology and some of the others would have a different technology, and half the panel would be spent arguing about technology, not about things that are important to customers. We've gotten to the stage now where the basics we're not arguing about those things. And we're differentiating on things that are important to us. We've worked quite a bit on ATTs LTE. We have the ability in what in LTE is high band spectrum, what in 5G is low band spectrum, if there is such a thing. And so that's an area where we have already rolled out AT8R, have a path to getting to 8x8 MIMO over the time as the devices allow for. And then applying those learnings to what we've done already to help with 5G. So we've been working on that quite a bit in the industry to provide our perspective on that and where we should go collectively. We have publicly done a demonstration at Copa America. About 200,000 people who attended those soccer games had a chance to see 5G in action at a couple of different vendors, a couple of different bands. And really, they don't care about 5G, they don't care about the name or the technology behind it, they care about the applications that are enabled. And they got to see some very interesting things that will be in all of our futures, but today are really only available in demos. With that, I'll let Timo talk.
All right, good morning everyone, and thank you Tom, and great job pronouncing my name. I know it's not the easiest under the sun, but you did really, really well, so congrats on that. I hope you've all at least heard of T-Mobile. I know we kind of are the new kid on the block, if you will. Maybe not new, but up and coming, if you will. And it's pretty early still, at least by Vegas standards, so I want to start by talking a little bit about who we are and where we are today, and then reflect 5G on that. So of course, in the core of our business, we are the Un-carrier trying to fix and solve customer pain points. But if you put that aside for a moment and look at our network, we actually have a pretty rocking network as well. And it really builds on 3 pillars. It's about speed, the fastest network. It's about fastest growing network. And it's also about fastest advancing network. And when it comes to speed, we have the fastest network in the nation, and we're very proud of that fact. And it's great because it allows our consumers or our customers to enjoy mobile internet to the fullest. The way we see it is that all content is moving into the internet and all of internet is moving wireless, so having a well-performing fast network is a really, really great starting point. We also recognize the fact that coverage is really important, and we relentlessly spend endless days and nights building our network, and in the last year or so we added about 1 million square miles of additional coverage, and that's huge. I'm originally from Finland, which by European standards is it's not that small country, but when I compare the landmass of Finland to 1 million square miles, I could fit 8 Finlands into that 1 million square miles. So that just blows my mind every time I think about it. So it's huge. We have a lot of coverage, 312 million covered POPs today. So it's really everyone in this great nation can enjoy our services pretty much. But it's not just any network, it's really the most advanced network. And we've been pushing the technology limits constantly. And if you look back in kind of the couple of last years, every meaningful network innovation has first happened in T-Mobile's network. Whether that's voice over LTE, and about 60% of all the voice calls today are handled by our LTE network, or whether that's HD voice or its evolution to enhanced voice services or EVS. Maybe it's Wi-Fi calling or international Wi-Fi calling or handoffs between LTE and Wi-Fi. All those things first happened in T-Mobile's network. We've also had an LTE Advanced network for a couple of years already. In 2014, we started with carrier aggregation deployment, and we've been adding LTE Advanced features ever since. And this week, we announced a couple of additional firsts, 4x4 MIMO or deployment of 4x4 MIMO, which allows us to double the peak speeds of a given LTE carrier without adding additional spectrum. And we also are deploying 256 QAM in the downlink, which again improves those data rates even further. So those are all great examples of how we push the limit of the network technology and always are kind of on the leading edge when it comes to some of these capabilities. So then when it comes to 5G, what does that have to do with all of this? Certainly, 5G is kind of a very important part of our network evolution strategy. It's not here to displace or replace LTE. It rather builds on LTE and complements it. LTE is going to be the workhorse of our network in the coming years, providing service and capacity and speed to our customers. But 5G will complement and enhance it, not just in terms of additional capacity and speed, but also additional capabilities and enriched experiences, something that the 5G technology allows us to do. So those two will kind of hand in hand go and move forward in the coming years. And 5G is really a technology that's designed to meet the needs of the next decade or so. It's not something that necessarily is only to solve what we have on our plates today. So it's not just about fixed wireless access, or it's not just about connected machines. It's really about all the good things that we enjoy when it comes to mobile internet. And that's where the true power and value of 5G lies, together with LTE and its evolution. We've been working on 5G just like everyone else for a while already, and it's really starting to come together. But we have a long ways to go. But the way I see it, it's looking really good and promising. And the next 10 years or so, it's going to be pretty exciting. Thank you.
Good morning. Tom, thanks for inviting me, and I'm honored and humbled to be up here with this dream team, and I truly mean that. I'd like to share my perspective on 5G, but let me start first with a little bit about our company, because we are quite a bit smaller than some of the carriers up here. US Cellular is the 5th largest carrier in the United States. Our primary markets are in the Midwest, but we do offer service in 23 states. We have one of the lowest churns in the industry. We're a CDMA-based voice carrier, but we have LTE deployed across our entire voice network, and north of 90% of our data traffic is now on LTE. We've also completed trials of VoLTE, and we're in the process of commercially launching that in our footprint. And we are kicking off trials for 5G this year, and there'll be 2 of them and maybe a third one before we complete the year. So let me share my perspectives on 5Gs. I think it's a very exciting time for the industry. For as long as I can remember, this is the first time that use cases and business requirements are actually driving the development of the technology as opposed to the other way around. And I think that's very cool. The other thing is interoperability and roaming are not afterthoughts as the technology is being developed. And that's particularly important for a carrier like US Cellular that depends on roaming agreements. And by the way, we just successfully completed LTE roaming implementations with 3 other carriers. And it's rather unique in that we're a CDMA carrier, but we can offer LTE roaming on a GSM carrier's LTE network. And that's something that we think is very innovative and just goes to show when there's a problem, the engineers figure out a way. Hey, Patrick, how you doing? Sorry, blast from the past. But 5G to me is more than just a waveform. You hear a lot of talk about waveforms. It's actually, in my view, a network of networks. And what's really exciting is the first time, I think, where all the different technology domains are moving at the same pace, converging to allow this seamless operability between Wi-Fi, licensed technologies, TDD, FDD, and of course LTE, which will be around for a very long time as our base technology. And I think all of that serves to deliver a superior customer experience when these technologies get out the door. So I look forward to your questions and interacting with the dream team up here. So I'm going to turn it over to Adam from Verizon. Yep.
All right. Thanks, Tom, for having us. Thanks, CTIA, for hosting. Thanks, Mike, for the introduction. A year ago or so, we were really public about our plans to do a lot of early 5G activity. In fact, we made several announcements at this exact show related to our thoughts on how fast that technology can evolve and why it's important. And to this day, I still get asked the same question repeatedly, which is, why are you still talking about this so much? Why are you doing so much now on this future technology? And the answer for me has always been very clear. When you look at the state of our LTE network today and the rapid evolution that's occurred from a RAN perspective, the solutions we put into the network and in front of customers, we're very far on the bleeding edge of that technology. It's got a long roadmap, it's got a healthy roadmap, and it'll be the base of the network for years to come. When you look at the core networks and their movement towards a virtualized domain, software-defined networks in the core enable services that we can't do today with a traditional network. That's another building block that gives us very clear line of sight to next generation technology. And last, when you think about the Internet of Things, which is often tied to 5G, that's a today problem that's being solved right now. At this show in particular, you'll see a series of announcements. You'll see a very active booth for Verizon related to the Internet of Things and how we're using today's technology to solve real problems in the world. That's yet another building block towards 5G and next generation networks. So when you look at that rapid advancement of technology in today's network, you start to focus on what has to come next to drive real value for the consumer, to drive real value for the business, and bring that technology to market faster. That has been our goal since day one. It's to bring next generation network technology to market, a commercialized path, a lot faster. And that's the crux of what we're doing right now with 5G. It's what our field technical trials are geared towards. That's what our ongoing global operator collaboration is geared towards. And it's a really, really exciting time to be in this industry for exactly that reason. So with that, Tom, I'll let you fire away with the questions on the panel.
Okay. Well, what an exciting time to be talking about next generation technology and how we're evolving 4G LTE. As all of the panelists and operators have talked about, 4G LTE is leading, really evolving and leading the path as we define what we want to do with 5G, and will be the workhorse technology for years to come. So let's talk a little bit about LTE Advanced and what it really means. So maybe Tom, I'll start with you. Can you tell us what this is for some of our audience, who may be a little less technical? What does it mean for the consumer?
Well, when you actually look at the LTE Advanced capabilities, so voice over LTE is maybe the first feature that consumers really took note of. But when you go beyond to the actual speeds and performance LTE's been able to deliver, that's largely been a function of carrier aggregation and what we've been able to do by combining bands together for greater bit rate. When you look into the future, that will still hold. We'll use carrier aggregation to help us with unlicensed spectrum to really drive that performance even higher. I think you've seen 256 QAM mentioned in higher order modulation. That's another advanced technique that will allow us to deliver that performance. But what it's really about is making sure that our customers are able to do what they want to do with their tablets, their mobile devices. And that's why we're following this path to LTE Advanced. You're going to see it improve with release 13 and beyond to LTE Advanced Pro. The new IoT functions we mentioned are in that category. So as I mentioned, for the next decade, you'll see this network be the baseline for what mobile operators use. And along with that, we really need a roadmap to support it, and that's really what it means to us.
Okay. Kari, you mentioned some of the things that are going on in your network. Can you talk a little bit about specifically what you're doing with LTE Advanced and maybe what might be different from what AT&T is doing?
Yeah, I mean, obviously, LTE as a technology is defined by 3GPP, and consequently, all these capabilities are sort of available for everyone in the same way. But how you deploy and how you take these capabilities into use may be a little different from case to case. Like I said in my introduction, when we build our network, the LTE network, we build it with LTE Advanced in mind, and we've always had this mentality that we want to bring in these new capabilities and new technologies as aggressively as we can so that our customers can benefit from those capabilities. And on the LTE Advanced side, it started with carrier aggregation, and like I said already 2 years ago, it started with 2 carrier aggregation, and obviously that's now evolving into 3 carrier aggregation where you can combine 3 different LTE carriers to provide additional capacity and speed and better experience to the end users. But there are other capabilities too, some that are maybe not that visible, but certainly if they were not there, it would be a little bit more, or the experience might not be as good. And VoLTE is one of those examples, maybe enhanced voice services that will improve the voice quality, and especially when it comes to high definition voice and music, that quality even further. Absolutely. And then when it comes to these advanced speed and capacity related features like 4x4 MIMO and 256 QAM, we can expect that you can get much better speeds than what you get today and kind of a better experience in general. So all this is geared towards, and I agree with Tom, to kind of provide the best possible end user experience when it comes to accessing these services in our network.
Great. And then Adam, Verizon made a big announcement last week about LTE Advanced. Could you talk a little bit about that and then what that means, and as well, like what does it imply for being able to refarm spectrum and manage other technologies?
Yeah, sure. Just, and for context, if you go back a few years when we deployed our AWS 1 bands of spectrum on top of our 700 megahertz layer of LTE coverage, we had basically a tripling of capacity across the network just by deploying a second band of LTE services. So that was a huge shift and change for our consumer base. They got great benefit out of that and continue to do so today, obviously reflected in the results of the network. And looking forward now, as our EVDO traffic declines rapidly across the network, we're freeing up bands of PCS spectrum that was previously used for EVDO services. So carrier aggregation fits perfectly into that equation when you've got 700 megahertz band, an AWS band, PCS band. The network and the device are intelligent enough to pair the bands to best serve the customer on a sector basis. 3 individual users could get a different pairing on that same sector just using 2-band carrier aggregation, with 3-band carrier aggregation following shortly. So that refarming process for us has been critically important to get the most use out of the spectrum we've already deployed with the most advanced services. And when you tack carrier aggregation on top of that, you create a really robust experience for the consumer.
Thanks. That's great. Ron, your experience at Sprint's a little bit different because you're using spectrum a little different way. You mentioned it a little bit, but can you explain to us, like, what is time division and how is that different in terms of either opportunities or challenges for Sprint as an operator with utilizing the spectrum that way?
So
Go ahead.
of the 3 bands we have, you're referencing the 2.5 gigahertz band, band 41 and LTE. We actually, because of some legacy reasons with the spectrum, we actually had our choice of FDD or TDD in that band. This dates back even to Clearwire when Clearwire was the owner of the spectrum. We chose to go TDD for a couple of reasons. One was quite simple. We couldn't pair as many POPs covered with FDD as we could with using the TDD. And there's a lot more innovation and a path to further innovation that exists in TDD, we feel, over the long run, especially at these higher frequencies where you start being able to do things like beamforming, which we've launched today, are much more effective when you're actually using essentially the same spectrum for uplink and downlink as opposed to separated 100 megahertz or so. You're sampling the channel better. So we use that quite effectively. Obviously, at the higher frequencies, antennas are smaller. You can do things like put 8x8 antennas up, which you can't do or wouldn't want to try to do in a lower frequency. And of course, as we move to 5G, we're just talking about higher and higher frequencies and the ability to leverage similar innovations as we go up the frequency scale to smaller access points with even more antenna elements.
Great. Mike, your perspectives are a little different because, as you mentioned, your footprint is smaller, but you've still been very aggressive in terms of deploying technology, and now you're looking at 5G already. So how do you see that? How will 5G, in your view, sort of, we talk about inter-radio access technology, that sort of technology speak. What does that mean, and how important is it for us to be able to fall back to these LTE networks, which I think is important because we're all on LTE right now?
Yeah, I'll talk to that. I just wanted to share some comments on carrier aggregation. So we are deploying it as well, and our deployment is based on capacity needs. So we're not deploying it ubiquitously. At least in our footprint, we think the vast majority of customers, the applications they use, all that speed is sort of lost on those applications. But I do agree with my peers up here that ultimately those technologies are about delivering a consistent experience to the customer. And I think that, in the end, is what's most important to them. It's not about peak speed. It's a combination of speed, coverage, and reliability. In terms of 5G, I happen to think it's an imperative that you have seamless interoperability between the different radio access technologies when you think about all the diverse use cases that are contemplated for 5G. If you're focused on one specific use case, that may not be as much a requirement, but the holy grail is to be able to tie all these things together so that when you're in an area where the very high frequency isn't reliable, you can offer the customer access on a lower band, perhaps TDD or FDD, or even unlicensed. And so I think it's critical that the standards organizations, 3GPP, and the vendors really make sure that seamless interoperability happens, and it's not an afterthought. I think that's going to be problematic if we end up that way. And I think there's some vestiges of that we're trying to shake out now with the 4G and VoLTE.
Great. Yes, I think it's really important as we look forward to make sure we're collaborating well on the standards, the specifications, global roaming and interoperability, and as I mentioned earlier, cybersecurity is going to be important. You've already heard the folks at the FCC, wanting to make sure that we have secure networks, and it's always been our industry that's driven those solutions. So I think we need to stay out in front of that to make sure we, define that for the regulators so they don't define it for us. Speaking of defining 5G, Verizon recently announced a 5G specification. Maybe Adam, can you talk a little bit about that, what that's all about, and then how does that relate to the overall standards process?
Yeah, so last August or so, we started the Verizon 5G Technology Forum. It's comprised of us and obviously several of our technical partners, some venture capital firms, representing the chipset infrastructure and device vendor community. And the goal of that forum was to take the innovation that's occurring in labs across the vendor ecosystem and bring it into a real-world environment as fast as possible. And we, working through that process, we see that there's opportunity for early use cases using 5G technology, and the fact that the FCC is now committed to opening up bands with very large swaths of bandwidth in the millimeter wave spectrum range. There's an opportunity there to look at early use cases for 5G. One of those, of course, is a fixed wireless application. And so throughout this process of working with our forum partners and other operators in the community, we found that there's kind of very clear early specifications that are geared towards a fixed wireless use case that would enable getting out of labs and into field technical trials with basically a specification that can be built by vendors in the near term. So we committed kind of from the beginning to have a fairly open process in that regard, in the sense that the specifications that we target for these early use cases will be open and shareable. They are in fact on our 5gtf.org website. There's a series of specifications that have been released. And our expectation is that throughout the standards process that follows over the next several months and possibly years, that a lot of those specifications are adopted into that process. So that was the goal behind the release of those specifications.
Great. Maybe Tom, can you tell us overall what's happening with the 3GPP process? It seems like it, with everybody trialing quickly, it feels like it's slow, but I think there's a lot of people working on it to try to make it the right standards and specifications for what we need. Can you comment on kind of what the timeline is and what you expect to happen over the next few years?
Sure. So the existing timeline, if you were to ask right now, it's publicly set release 15 for sometime around mid-2018. But you've probably also seen some collaborative efforts that certainly AT&T and many others here have had to try to advance that. So ideally, to Adam's point, if we can accelerate the actual standard and actually build a technology with global economy of scale, which we believe is critical for commercial deployment, we can be out to market faster with that technology. So ideally, if we can start with the chipset requirements, if we can build those in to where chipsets can be basically standards compliant by the end of next year, that'll give us a jump on potentially delivering 5G to the marketplace sooner. So that really is, I think, the global industry effort to move those standards forward from mid-2018, ideally into late 17.
That'd be great. I think it's a collaborative work of all these folks as well as others in the ecosystem, the suppliers, chipset manufacturers, device providers that's helping to really drive this forward. I think all of you up here have announced some sort of 5G trials, demonstrations, shaking out the technology. Maybe could you comment on where you are with those? What are some of the key learnings? Ron, you want to start? You mentioned Copa Americas. What are the types of things, maybe one or two things that you've seen, so others can in the audience can understand what are the things we're starting to learn in the early stages of this technology?
The public demos versus, to use a term that we use internally, demos versus trials. The public demos were obviously more focused on consumers, and that's only a small subset of what obviously 5G promises to address. I think that in the end, what people experience is not 5G, and as much as we like our Gs, and as much as the marketing folks can start confusing the waters with different terminologies for the Gs, in the end, people there's a lot of new and innovative ways the network can be used. I think that what I learned was, in part, was latency is something very hard to describe to people, why they should care about it. We tried to demo that with an inverted pendulum where, with LTE latencies, basically the intelligence was in a laptop on the side. The latency was so long the laptop couldn't keep the pendulum upright. That doesn't really gel with people. But what's interesting, people look at it and they kind of get the idea. But I think one of the killer apps, I don't know how it will be used in everyone's network and exactly how it will finally be used, is virtual reality. Clearly a lot more bandwidth. But also latency is very important. If you're wearing a virtual reality headset and you turn your head and then there's a delay. It could be in the order of a few milliseconds, but it's enough that your brain recognizes it. You're more likely to get sick. And so reliability and latency and things that we take as important to our networks take on a whole new meaning when people get physically ill if the network isn't performing well enough. And there's very interesting applications, obviously, in industrial, but even in everybody's individual lives, virtual reality being a great one.
Yeah, I'm glad you brought up virtual reality because I think it's one of those things, it's just on the cusp of taking off, whether you see educational applications or healthcare, gaming, there's certainly entertainment, but there's all kinds of things whether you can offer students the opportunity to go on a global field trip and get a real 3D experience, or whether you can do something with remote medical. You mentioned kind of remote, real-time remote capabilities of robotics or some other kind of manipulation. So I think you'll see a lot of these things out on the show floor, and there's a lot of the potential things and things that we've never even thought about, I'm sure, coming up. Kari, T-Mobile's doing some trials as well. Can you comment on kind of what the nature of those tests?
Yeah, I mean, we started working on 5G already last year. We moved into, call it a proof of concept trialing phase earlier on this year, now moving out of the lab into the field. Obviously, there's work to be done. It's still early days. Standards are not completed. Everyone's working on figuring out how it actually works and how to miniaturize the equipment to a form factor that's something that can actually be deployed both on the network side as well as on the device side. But what really I think is great is that we've been able to see that some of the things that are typically associated with 5G, such as massive MIMO or harnessing the millimeter waves, beamforming, low latency, that they can be achieved. They are real, it works. And having that foundation in place is awesome because it kind of gives us faith that we can execute on the plan that's in place today and maybe even accelerate that a little bit, hopefully, reaching the goal of having standards-based 5G technologies up and running towards the end of this decade. So there's work to be done, but as far as I can see, I've already kind of ticking that box that yes, the foundation is in place, it can be made to work. And on one hand, it's easy to kind of oversimplify this by saying, what's the big deal? It's just another frequency, and what's the big deal? You add a few more antennas, and the smaller wavelength size allows you to do that. But as an engineer, it's impressive. I mean, it is a huge step change in terms of complexity and being able to do what we want to do with 5G. And to see our partners kind of deliver and be able to get it work already today is something, hats off for that. It is worth recognizing, so that's great. And those are kind of the big learnings so far. But next thing, obviously, is to go and start looking at how do you actually deploy, how do you create all these capabilities on top of it, what use cases might work. And to Ron's point, it's not just about technology, the technology works, but it's also about how the applications work and what are some of the benefits. If I want to do virtual reality, what does that really mean in practice? And those are the things that we're going to have to look at. So it's not just the technology, but also the application of the technology. And both of those things are moving forward nicely.
Right. So one of the things that I mentioned earlier, it's important, obviously, is spectrum. And earlier this year, just a couple months ago, the FCC voted to approve its Spectrum Frontiers order, which brings forth 28, 37, 39 gigahertz bands, very large swaths of spectrum, 200 megahertz wide versus something that's either 5, 10, or 20 that we're dealing with today, the 4G LTE. So those are licensed bands, and then unlicensed bands in the 64 to 71 gigahertz range, and then future study items for bringing more bands to market. So maybe, Tom, you can comment a little bit on what are some of the characteristics of these bands that make it both an opportunity, and maybe I'll ask some of the other panelists what some of the challenges are.
So I'll point out two. The first is bandwidth. So in the 28 gig range, it's, I think, 850 megahertz of bandwidth. If you look at 37, 39, there's up to, I think, 3 gigahertz of bandwidth. So we're dealing with very large channel sizes, 10 to 20 times what you would see in an LTE network today. That allows you to achieve some great performance. Now, on the other end of that spectrum, it's very high frequency. And if you put your hand in front of a transmitter, you're going to see performance degradation. So again, part of what we're doing with trials is to understand that this is a spectrum band that's never been deployed before for this use case. And it's going to be a very different implementation than what you've seen with existing cellular networks. So I'll stop there, and these other folks can explain some of the challenges, but that's our view of it.
Okay, maybe Ron, Tom mentioned some of the, sort of alluded to the propagation characteristics. You're seeing that with some of your 2.5 gigahertz, but obviously at a considerably lower frequency. But maybe can you comment, based on your experience at Sprint, what some of those challenges might be in terms of deploying small cells, and what do we need from cities and municipalities to help us help streamline things?
That's almost two different things. I'll start with the spectrum side of things. 2.5, certainly when you compare it to 700, it doesn't propagate nearly as well. It has a lot harder time penetrating walls, but it's not nearly the same as 28 gigahertz. So I actually see 2.5 as being an interesting coverage layer, if you will, in 5G, if there is such a thing, as opposed to sort of more of a hotspot, very line of sight or very small area sort of deployment. The small cell question exists today in 4G in terms of the issues that are inhibitors to deploying small cells perhaps as much as any of us would like to. The biggest, from our perspective, the biggest issues are siting and what that complexity of doing that and the cost of doing that and the backhaul. And I think that those get to be potentially even an order of magnitude bigger when you do 5G, because you're talking about even that many more access points. I think right now we have a point of view as to how we would like to do it in LTE, and let's just say we're in the midst of doing that, and I'm not going to say how we're doing it. But we think we have solutions to both of those and moving forward on that. The scaling of all of this to a 5G will be an interesting challenge. I think that it will require solutions that are not just technical in nature, but also, shall we say, political and contractual, and all the things where, as you go into deployment, all the expectations that people in the ecosystem have as to how they will interact with an operator to deploy equipment may have to be very different. The cost to cover every conference room in this ballroom, all these ballrooms and meeting rooms, is going to be very different from a 5G perspective, and the ratio of equipment to sort of OpEx to CapEx ratio will potentially be very different as well. And so there's going to be some unique challenges there.
Adam, any additional thoughts about deployment and so forth from what you've seen?
Just to echo the first point made, the fact that we were able to talk about 5G dedicated bands is a fantastic accomplishment. I mean, that should not be understated ever. I mean, that's a lot of action in a short period of time to create and spur a lot of the innovation we're even talking about. So that's fantastic to start with. And the propagation characteristics of millimeter wave bands are well known. There's nothing new there. What has been new and has been a lot of innovation within the technical partner community has been concepts like beamforming and beam tracking, certainly the massive MIMO, that enable the use of those bands in an access type deployment. So our technical trials have been geared towards taking those concepts out of the lab and putting them into kind of real world deployment scenarios to see what kind of design is needed to overcome, say, propagation challenges, to take advantage of the reflective characteristics of the bands, so that when you're designing a solution for a consumer application, you have the right node placement, number of nodes, backhaul sizing, and all those things. Additionally, what that leads into down the road is using a wireless aspect of that for backhaul as well. So when you're talking very large swaths of spectrum, you have opportunity there where you can use some of it for backhaul and some of it for access. So that's all really what our technical trials are geared towards, proving out those characteristics and finding the advantages of the bands as opposed to the limitations.
Great. So Mike, you mentioned that you're thinking about 5G trials. What's kind of your interest? Are you trying to shake down the technology or just get some real hands-on experience? What are your thoughts there?
Yeah, thanks, Tom. So we're kicking off our first trial actually next week. It'll be in the 28 gigahertz band with one of our incumbent vendors. And then on the heels of that, we'll be doing a 15 gigahertz trial. and then possibly a third one. So those are underway. And it's really to understand the propagation characteristics. I do agree with Adam. It's well known. There's a lot of research already on those bands. But as an operator, you want to become intimately familiar with the limitations of the technologies. I think a lot of the focus, at least for us, will be over the coming year is understanding of all those bands that have been made available, what services work best on which bands. All of them are very high frequency, and so the range is much more limited than what we're accustomed to. Some of that's offset by the advanced beam forming. But I think determining which services are well suited for which bands is going to be a lot of the understanding we need to grapple with.
I want to shift gears for a minute, and then we'll go to the audience for a few questions. We talked a lot about the radio. We talked about spectrum. We talked about the radio access technology, multiple antennas, and so forth. But we didn't talk too much about the core. I know AT&T is very, innovative in terms of leading, one of the leading operators in terms of moving towards function virtualization and actually software-defined networks. Can you tell us a little bit what is that all about? And secondly, is it important? Is it critical before you launch 5G in your mind, Tom, or is it something that can you do afterwards?
So it absolutely is critical. I would even call it table stakes. In 5G, there's a concept called network slicing. And the idea around network slicing is to allocate the minimum resource required for the application use. As an example, there's a very different requirement for delivering 10 gigabits per second to a mobile device than there is to deliver 200 kilobits per second to a stationary IoT device. And most certainly, you would want to allocate only the required resource for the function at hand. In order to do that, we would use network slicing. And part of the requirement around the ability to do that is to have a virtual core. You're going to see virtualization occur in the RAN as well, but certainly it would start in the core. And that's one of the reasons why you've seen some of the big efforts in the LTE space already. In fact, we've already got a virtual core operating, serving several million customers. So all the learning from that will go right into what has to happen in the 5G space. But you will see virtualization happen first in LTE, but then it's almost a certainty in the 5G area in order to make that technology yield all the efficiency and benefit that it can.
Great. Kari, any additional thoughts on functional virtualization? Is that important before you deploy, or No,
you're right. I mean, if you look at kind of 5G and it's more of an evolution in the radio access space, and you could say that it's more of a revolution in the core network space, and that's really boils down to slicing. It's to enable low latency applications. You're probably going to have to push more intelligence towards the edge of the network. So there's stuff that needs to be done on the core network side, and I think we have, a pretty good starting point on our side. So we're not necessarily don't have a huge legacy that needs to be modernized to enable that. I think we're kind of already on our way to get there. And that's why kind of our efforts are focusing right now on the radio aspect side of 5G, knowing that the core network will kind of follow, and it's maybe something that we can do with relative ease.
Great. So why don't we take a couple of questions from the audience, if there are any. Okay, over here, please. Right. Do we have Paula will bring you a microphone so everybody can hear the question. Okay, if you could state your name and who you're
Sure.
from. Okay.
Thank you. My name is Mike Dano, and I'm with Fierce Wireless. And I wanted to ask about LTE unlicensed. And my understanding was that Verizon and T-Mobile were hoping to launch LTE unlicensed this year. And my question is if that's still going to happen and kind of what's going on there.
Yeah, good question, Mike. Technically, there's nothing preventing that from happening. What we're working through right now is the back and forth with groups like the Wi-Fi Alliance to prove that LTU can be a wonderful neighbor to Wi-Fi, which we have proven time and time again. So we expect that to get resolved fairly shortly. And again, technically, there's nothing preventing that from occurring from an infrastructure standpoint. So we're confident that the testing we've done and exemplified and shown over and over again is sufficient.
Kari, anything to add? Or
I mean,
much captured?
I think Adam covered it really, really well. There is that regulatory situation that needs to be resolved, but the technology is kind of ready to go. It's been shown many times that it is a good neighbor to Wi-Fi. For T-Mobile, Wi-Fi is an integral part of our business, very important to us, so we really want to make sure that that actually is the case too. So there's really no incentive for us to jeopardize Wi-Fi in any way. So yeah, it's looking really, really good. And the benefit of unlicensed or adding unlicensed spectrum into the portfolio, of course, is that it's additional spectrum that we can use to add capacity and speed, which eventually benefits our customers. So that's sort of the idea behind it. But yeah.
Great. Next question. Over here on the side. I'm making Paula run back and forth here.
Hi, my name is Diana Guvertz. I'm with Wireless Week. I just wanted to touch base on the 5G specifications that you, Adam, at Verizon released. My question is kind of centered around what happens if those standards aren't the ones that end up getting adopted by the 3GPP. What happens then to all the work developers have done based on those open standards, and where do you go from there?
Yeah, so the beauty of the specifications is they've been developed with the same infrastructure partners that contribute to the standards process. Just 2 weeks ago, or last week, there was a 3GPP meeting. A lot of that discussion already occurred related to what parts of the specification will be included in the much larger effort to tackle the 3GPP standards for 5G. So a lot of that discussion is already occurring. Our view there is that with the evolution of software, any changes that would have to occur for the full standardized process of those specifications we'd be fixed with software primarily. So we've been really focused on the early physical specifications that would feed into that larger 3GPP process.
Okay. We had this gentleman here in the blue shirt.
Say your name, your company, and your question.
Yes, thank you. My name is Ray Chang. I'm from FNC. I just have a question about the 5G air interface. We understand that there was a lot of a fight. Different kind of interface was trying to made into the standard. I'm just interested to hear what's the latest. Is still going to be OFDM or is going to be something else?
Anybody want to take that?
Yeah, I mean, I think a lot of those issues, there's sort of working assumptions, but there's still further dialogue taking place where things will be formalized. I think it's also good to recognize that the 3GPP specifications have sort of been split into two different phases, and the first phase seems to be focusing on enhanced mobile broadband aspects. OFDMA seems to, a variant of OFDMA seems to be kind of the de facto assumption for the air interface, but that doesn't mean that it would necessarily be the best waveform for applications like IoT down the road. So we'll have to wait and see for the full specifications to be completed to really have an answer to your question. But it is, I think, last week and then in the next plenary, which is taking place shortly, I think we will see progress where kind of things start to come together. And all this is needed so that we can meet those aggressive timelines that are in place, having a really good consensus by end of this year on what sort of the first phase will consist of, and then tracking progress March 2017, and then hopefully having layer 1, layer 2 kind of nailed down end of 17, and then finally full release 15 specification by mid-18. So there are multiple milestones in between that need to take place before we have all those answers. But the way I see it, and when I look at what's going on in 3GPP and the progress that's being made, it's looking really promising right now.
Can I add something to that, Tom? So all the specs I've read, it looks like it will be OFDM. The differences are in the filtering and the windowing that's used, which I don't think changes the fact that it's going to be OFDM. Probably the biggest difference is between the downlink and the uplink. It looks like the uplink will be a version of single carrier OFDM, and the downlink will be multi-carrier. I do agree with Kari, though. They still have to figure out how to support non-orthogonal transmissions for IoT. And that's probably less a waveform issue and more about how the scheduler treats the transmission between the different roles. But I think that's a good thing because you can leverage a lot of what we learned with OFDM and LTE in this next generation of technology.
Okay, we've got time for one more, and then I need to wrap up here.
Thank you. Ken Rabin from 451 Research. Thank you for some very interesting observations from people whose feet are being held to the fire. So we have phase one, we have phase two, and I've heard some operators around the world talk about phase two as being perhaps an opportunity for more radical change in network architecture approaches to RAN system design. An example would be perhaps moving away from cells to a cell-less type of architecture. So in your wildest dreams, when you're awake at night thinking about what you'd really love to see happen in innovation, what kind of runs through your mind for a phase two or maybe even further down the road, a phase three? What can we do? That'll be interesting.
I'll take a stab at it. I mean, I don't dream about the radio stuff in my wildest dreams. See me over a drink and I'll share that with you. But I think, I mean, there's a lot of talk about the cell-less technologies, and you know, MIT has published some research. There's some companies out there offering it, and my view, it's really a more evolved version of Mega MIMO, where you're concurrently combining the different waves from the multiple antennas to really, you know, improve your performance. But I think that's a ways off. That's not going to be like, in my view, phase two of 5G. Because there are a number of computational issues that have to be solved to make that practical. If it is to get deployed anytime in the next 5 years, it's probably going to be in very concentrated, dense hotspot areas where you can combine the baseband and get a lot of computing power. But I think right now we're best served focusing on what's going on in the standards organizations to get 5G out in a practical way, dealing with real use cases.
I think, you know, it's interesting. We had a keynote at the NYU Brooklyn Summit earlier this year, IEEE community, and the challenge that was put to the academic community and all of these EE majors was, this is the background of what's going on right now. This is why operators like the ones here on the stage think 5G is important. This is the work that's gone into evolving wireless technology over the last several years. And what we want them to think about is exactly that question. So what happens after the what's known and how the architecture is going to evolve based on what we know today? So the facts are, you know, we've got extremely dense networks today. We've got a highly advanced LTE network. We've got the opportunity to use large swaths of millimeter wave spectrum for a network of the future. And you can only see so far ahead with that in mind. And so the task to that engineering community is along the lines of your question, which is, what do you do beyond that to shift to something more dramatic from an architecture or design standpoint or from a technology standpoint? Those answers aren't known yet, which is actually the coolest thing about what we've been talking about. Because as far out as we can see right now, you know, the engineers in the room can kind of put their head around that and put some real tangible things in place, and we certainly see it in the field trials we're doing today, the way the technology is evolving. But then there's a whole series beyond that that we haven't gotten to yet, and that's the really cool part, at least in my view.
And I think that, real quick, that, you know, the theme of some of this was really how the U.S. is leading and has led in LTE and has starting to lead in 5G and will continue to. I think part of that is the basis of our academic institutions that really focus on these areas and can provide those innovations and spin off startups that can form entirely new technologies. And, you know, all of us, I believe all of us, most of us are supporting the Advanced Wireless Research Initiative, which is intended to give them a bit more concrete idea of the playing field, if you will, and some place to test bed their technologies in a way that they don't have to worry about dealing with a municipality and licensing and all the things that we have to worry about, but they can get stuff out there and get things out of the lab and research it quickly. And that's what the U.S. is good at, is those types of environments.
Great. Well, we need to wrap up here, but I just wanted to give you some closing thoughts, and I'll ask each one of our panelists to give kind of their input on what's the one thing that makes you most excited about 5G. So in the meantime, I'm coming off the Summer Olympics in Rio, We know that announcements have been made about Korea demonstrating 5G at the 2018 Olympics, and then NTT Docomo in the Japanese demonstrating it in 2020. That's one of the things that makes me excited. What are some of the new applications, either in virtual reality or other ultra high definition that they're going to bring to us? And I'll ask each one of our panelists to give a quick, their brief perspective, and then we'll wrap it up. So, Tom?
Well, so if you look at 4G, largely that's been a consumer-type technology. And it's been phenomenal what we've been able to deliver there. But I think for the first time, as we designed 5G from scratch with the thought of handling not just enhanced mobile broadband, but IoT, low latency, and all the other functions we can do with that reduced latency, high reliability. For the first time, we're going to really enable the industrial world to move into a mobility realm. And I think that's pretty exciting about what 5G can yield a few years from now.
I agree, and I think that what makes me excited about 5G is also gives me some reason for caution, which is we're really talking about an umbrella that encompasses a vast swath of capabilities from IoT and narrowband and very small channels to very wide channels, obviously, and millimeter wave. And what I want to make sure we as an industry do is keep our eye on that interoperability and making sure that over time we don't make this a balkanized set of sort of interrelated standards that there may be some need for it because IoT doesn't need to be mobile broadband, but at the same time, we don't want to be up here each with our own version of 5G and sparring over the bits and bytes of it. We want to be up here talking about customers and applications.
Yeah, it's getting harder and harder to add anything meaningful on top of these two comments. But
Good luck.
Yeah, exactly. So, but anyhow, I mean, 5G it certainly is exciting, both in terms of making what we use mobile internet for today much more, I don't know, kind of improved experience, but then also opening up these new opportunities that you can tap into as it makes sense, to you as a company. So it's a bit of both, making what we have in place today better, but then also looking at new opportunities and new capabilities that we can bring on top of that and kind of spread the wireless technologies to cover a wider area of capabilities and industries. So that's, I guess, is the exciting piece.
Yeah, I would say 3 things. A chance to make money. 2, we're starting with use cases which will improve the odds we will make money. And then the 3rd thing is we're going to have lots of issues, but I'm confident that the industry will overcome those issues and really deploy a strong, healthy ecosystem to thrive in. So, cool times.
Adam,
the thing that excites me the most is when all this stuff that we just talked about, all the technical details that our engineers grind away over day in and day out, the value that they see in all that hard work behind the scenes is at the end of the day, our customers get the best, most reliable network experience they could possibly achieve in a fixed or wireless mobile environment. I mean, that's the whole mission of our engineering community. And with this in front of them, where they're tasked now with surpassing the functionality and reliability and robust characteristics of 4G LTE and charting the path to what's next, they are all intensely energized by that challenge. And that's what gets me excited, because the people that we have creating this stuff day in and day out are energized like they haven't been before. So that's my view.
All right, thank you very much. Let's give our panelists a quick.